In this nugget, we'll talk about cryptography. We'll start off talking about the basics of cryptography, and we'll address the difference also between symmetric and asymmetric cryptography. We'll take a look here at key pairs and how they can be useful, and I'll show you that in a demonstration here coming up as well on how you can practically use that. And then we'll take a look at actually using encryption. There are several demos where we're going to use different types of encryptions for different purposes. All right, let's take a look at some cryptography basics here. First of all, the purpose here is to primarily secure data between two or more parties. Now, besides securing data, such as in encryption, you could also use it for signatures to confirm parties or confirm identities. But that's very often how we think of cryptography as securing data. And it can be used in a number of different ways. And of course, this is not a comprehensive list. One of those would be network. So if I'm just browsing the internet in a coffee shop and someone were to intercept what I was browsing, if they just see I'm going to yahoo.com or something like that, really no big deal, nothing really security sensitive there. But if I'm in a corporation that has highly sensitive emails that we're exchanging or highly sensitive files that we're copying across the network, maybe I'd want to use something like 802.1x, which could also implement the extensible authentication protocol, which allows us to use other security methods to be able to secure that data. It could be certificates that are involved, it could be Active Directory, number of different things like that. There's also IPsec, which is implemented in a number of different vendors, but Microsoft's version could, for example, use Kerberos, so that if both parties involved in the communication have a Kerberos Active Directory account, then they can not only authenticate each other, but also encrypt the data. SSTP is a version of virtual private networking. Actually, there's several VPN solutions, and almost all of them are really encrypted. The only one that's not very good encryption would probably be PPTP, or point-to-point tunneling protocol. But SSTP, as an example at least, implements SSL the same way we would when we would be doing online transactions at our bank. Okay, it's just using SSL over VPN instead, and it requires only that port 443 is open on a firewall. That's one of the advantages of this type of VPN, and etc. There's a lot of different ways to encrypt your network traffic. There's also the internet. Of course, if you're doing online banking, you want to see that favicon up in the upper left that shows actually it's not just a favicon, it's really the padlock symbol, identifying that we're on an HTTPS connection and we're transacting using TLS or SSL. So that's one of the other ways that we would secure the data. Healthcare, if you make doctor's appointments online or if you fill prescriptions online, that sort of thing, you want that secured as well. Email, you can sign and or encrypt. If I sign an email, that means that it definitely did come from me. There's nobody else that could forge that signature cryptographically speaking. So for example, if I'm using certificates to do that, very, very difficult, if not impossible, to really fake that signature. Or I could encrypt it so that if someone intercepts that email over the wire or something like that, they're really just going to get an encrypted blob of pretty much nothing that's virtually impossible to decrypt using just conventional methods anyway. Or even if they can decrypt it, might take a long, long time and significant processing power. Now there's also algorithms that are involved in this. Let's take a look at that. And really all that is, it's just complex math. It's way beyond me in terms of math. I can barely balance my own checkbook. But the people that come up with this stuff are mathematical brainiacs. A lot of them are involved in the university scene or professors or just professional mathematicians. A lot of them work for agencies like the NSA and so on. Anyway, they use these extremely complex math to encrypt and then decrypt whatever the data is. A lot of the types of math that are involved, or at least the names of them and a description, can be found on the document that I've made available for you. That's the CEH Study Guide. And once again, that's going to be available on our website here in the Download Files section, so be aware of that. There's a lot of stuff there. In fact, you're really going to want to read that document regarding cryptography, hashes, all of that stuff. Also, most encryption is block stream, also known as block cipher. So the way that works out is, if this is a file, what will happen is encryption doesn't normally just encrypt the entire file all at once, because what it'll do is to make it more efficient by breaking it up into blocks. So maybe there's a block here, a block here, a block here. Let's say that each one of these represents 64K. All right. What it'll do is it'll run the encryption algorithm against this, and then it will, out of that, generate. Okay, let me draw this in. It'll generate an encrypted block right there now. And it'll do the same against this next block right here, and that will also be encrypted, and encrypted, so on, until now we have an entirely encrypted file. When it comes time to decrypt them, normally we're going to use a private key. So we'll take the private key, I'll put PV for private, we'll run that against the encrypted blocks, and it will translate it back into plain text documents. I'll discuss that here again coming up shortly. And to perform that encryption, some kind of a key is going to be necessary both to encrypt and to decrypt it. Now, a couple of examples of this type of thing would be pretty good privacy, or PGP. I recently heard that Google is planning to use PGP for Gmail now, so that if you want to use PGP for your Gmail, then it would encrypt the data as you're sending those emails. Also, PKI, there's a lot of different implementations of PKI, but one of the ones that's gaining traction nowadays is Microsoft's version of this, which stands for a public key infrastructure, and Microsoft implements this as certification authorities. So let's take a look at the algorithms involved in this, and the first one would be a symmetric algorithm for encryption. This means that I'm going to use the same key both to encrypt as well as decrypt some kind of a message. Now, for example, this might look something like this if we were to look at it in a very rudimentary method. Okay, here's just some text. All right, this is from our web page. And let's say that I wanted to send a secret message. Oh, I didn't mean to click on that. I'm about to listen to myself blather on here. Hold on. Okay, let me go back. There we go. You're about to hear two of me there, people. Anyway, so let's say I want to send an encoded message. Well, I could take, let's say, some kind of a template. Okay, and I could just lay it over this. And you may have seen this kind of thing before, you know, from movies and stuff like that. And you just lay it over the top of this, and it's completely opaque, and you can't see any of the text underneath it. But we would punch holes in it, and we would reveal maybe a secret word. So, I don't know, let's try to think of something. How about it would open up the C, and then it would open up the something else. How about an A, and a N? I kind of blocked out the N there. And then a D, and how about a Y? So we can see from this that C-A-N-D-Y, I've now revealed a secret message of candy. Okay, so I got a sweet tooth, folks. It's kind of on my mind here. So anyway, so that's my secret message. Now, if I wanted to share that secret message of candy to somebody else, how would we do that using symmetric algorithm? Well, I would either have to hand them this exact same template or make an exact duplicate for that other person so that we both have the exact same thing. Now, that's how we would do that in a symmetric way. And of course, there's no actual math involved in that because we're talking about algorithms here, but it is a symmetric method. One of the reasons why we use symmetric algorithms is because they're fast. Okay, but the difficulty there is you also have a difficult key distribution. So if this is me and I'm communicating with this person and I send them an encoded message using symmetric algorithm, then that's going to be, let's just call this key 1. But now we have another person that I also need to communicate with. So if I want to conceal the information that I communicated to this person right here, and I want to conceal that from this person, then I need to have a separate key for this person. So I need key 2. And then if I have another person over here that I'm communicating with, I need key 3. That way I can communicate with each one of these and encrypt my data, for example, but I don't want them to be able to read each other's messages that I have sent, respectively. Okay? So that makes difficult key distribution because this gets to be a real mess pretty soon, and we have to have a separate key for each person that we communicate with. The keys also have to be protected. So even if we go back to my example of that little template that we'd overlay on text, if somebody else were to get a hold of that and it were to fall into the wrong hands, for example, then just anybody could pick that up and overlay it on the text and read the same message. Okay? Also, it lacks non-repudiation. Non-repudiation means that you can't deny that it came from you. Well, with a symmetric algorithm, it's easy to get a hold of the key, and so it doesn't really do anything to confirm that it really did come from you. It's just a key is all it is. Again, see the study guide for all the various algorithms. I've got a bunch of them there, and will be very useful to you, especially as a test taker. Now let's take a look here at asymmetric or asymmetric, depending on how you want to pronounce it, you know, potato, potato, but asymmetric cryptographic key pairs. And with this, we have a public key and a private key. Now, let's address the public key. This is not security sensitive. You can take the public key and send it to your friends and neighbors. You can impress everybody with your vast knowledge of the public keys. For example, I'll even show you something you probably already have on your computer. If you go into Internet Explorer and the browser options there, if we go to Content and Certificates, you'll see that you've already got lots of certificates on your computer. These are placed there by default with the installation of the browser or the operating system. And these are periodically updated as well through something like Windows Update. But for example, if I go down through here, we'll see that, Equifax, for example, or GoDaddy, they have certificates here. And if I double click on one of these, I can go into the details and go down through here, and I should be able to see the public key, and there it is. Okay, it's a RSA encryption with 2048 bits, and this is the public key right here. I could just take all of that, and I could show it to my friends and neighbors and impress them with my vast cryptographic knowledge. I could even pretend as if I knew what all of that meant. Anyway, that's the public key. So that's not really a big secret. They are freely distributed. You've already got some in your browser, for example, in certificates there. These will primarily encrypt things. So I could use a certificate to encrypt an email, for example, using my public key, and then send it to somebody. And then in order for them to read it, they would have to use their private key in order to read it. They can also be used to confirm signatures. And this can be used a number of different ways, for example, for software and things. But it's also used to confirm identity, so that we can use the public keys that we have here to confirm that the web page that we went to really is authentically the web page of GoDaddy or whoever it is that we've gone to visit. And then we also have the private key. This is extremely sensitive. So remember the certificates that I just showed you? Well, we saw that they have the public key in there. They do not have the private key. The private key at each one of those organizations is a highly guarded secret and very difficult to get to. And if the private key, for example, with GoDaddy there were ever exposed to the public, then everything that their certificates depends upon would be compromised. So they would have to revoke their certificates immediately, for example. And Microsoft's had to do that because their certificate a few years ago got compromised and they had to revoke it. So anyway, this is extremely sensitive and closely guarded. It does a couple of things. It can work with signatures, or it can encrypt or decrypt, in this case, data. Let's take a look at how that works. So if I have, let's say I have a file here, and it's in plain text. Now, plain text does not mean it's a boring notepad font or something like that. This simply means that it doesn't require any specific decryption or anything like that to view it. It's plain. All right, it could be a graphic, it could be a movie file, it could be a notepad file, anything. It's just plain, all right, unencrypted. So what I might want to do with this is to encrypt it. Now, how would I do that? I would take my public key, run it against the plain text file, and it would generate an encrypted version of that file. Okay, now this file is encrypted. How would I then decrypt that file? Well, then I would have to decrypt it by running my private key against that same encrypted version of the file, and it would return it then to the plain text version of the file. And this is what makes it asymmetric, because we have a separate key doing the encryption and another key doing the decryption. Now let me go ahead and kind of clear the screen here so I can show you something else. And let's also change my pen color to something else as well. I'll change it to hot pink because I'm feeling kind of sassy. Okay, so let's say let's say this is a driver file. Okay, we have a new thingamajig that you can plug into your USB port, and we have a driver that we wrote for that particular thingamajig. What we want to do, though, in order to comply with Microsoft's requirements for signed drivers only, is we have to take a private key, okay, and run it against the driver file. It'll generate, and this is very often a separate file, by the way, it'll generate a signature. I'll just put sig for signature. Now, what this means cryptographically speaking is that this private key, when it's run up against this driver file, it will produce a unique mathematical result over here in the signature file. And in some drivers, you'll actually see a file there that has the signature in it. And you can open it up even in Notepad or something like that. And it's a unique mathematical result. Okay. Then what I want to do is to use the public key, okay, and run it against the signature, and it will confirm that it is appropriately signed. If the public key runs up against the signature and it produces a different result than what it would have expected, then it knows that this is not an appropriate driver. It's been modified or tampered with or something like that. So to review that, okay, the private key signs and the public key confirms the signature. All right. So what kind of practical uses could we get out of this? Well, for example, with email, we could sign an email and or encrypt the email. Let's just go to an email client here. Now, depending on the email client that you use, they're all different. Okay, so if I'm going to compose a message here to, I don't know, yuhu@cbtnuggets.com, I could say lunch. I could send a message to this person. I could say, oh, let me think of something. I saw your lunch in the fridge. It was delicious. Okay, so I ate this person's lunch, all right? Now, if I were to go to options here and then security and digitally sign this message, and if I were to click on send and send this to that person, I hope there's nobody at CBT Nuggets that's actually named Yuhu, but anyway, if I were to send it to them, then I would not be able to deny this in the future, because since it's got a digital signature, it could have only come from me, and I would have to have, of course, on my computer a certificate that corresponds with this signature. But anyway, I could also encrypt it, because maybe I don't want anyone else to know that I have eaten this person's lunch either, and you can see now it's both been signed and encrypted. And when this person receives the message, they'll use their public key to confirm the signature, and then they will use the private key to decrypt it. Okay, so they're going to use both keys in this case. And as I was mentioning earlier, you can also use it to sign drivers or software. You can use it for SSL TLS webs. That's where, of course, you enter an HTTPS into a site, or if you're redirected to that, for example, at your banking website. Then there's the two-factor authentication that you can use as well. There's certain security tokens that have certificates on them, for example, and these tokens very often will require that you not only have the certificate on that token, but you also have to enter in some kind of a PIN code or something like that, and that's very often the case, or usually the case, with smart cards. So a smart card, for example, will have your certificate on there, and you'll also need to enter in a PIN. And this will take the place, normally, of using a conventional logon where you have a username and a password. Although smart cards can be used for a lot of other things as well. Now, I want to briefly revisit the driver issue. Remember I said that you can sign drivers, and that's a requirement by Microsoft for all current operating systems. I went to sig.com here, and you don't need to memorize that or anything, but I just went to sig to look at some driver files. They make drivers for their devices, which are usually some kind of a storage device. This is an eSATA device. So I downloaded the driver. It was a zip file, which I expanded, and here are all the files. Okay, so notice there's 5 different files here, and the drivers themselves are .sys files. There's an accompanying application extension, which is the DLL, and the INF file provides instructions on how to install the drivers, such as what registry changes to make, where to put the files, things like that. And then here's the security catalog, which is where the signatures come into play. Now, if I double-click on that and drag this so we can see it, what we see happening is a few different things. Number one, let's go down here. We can see a lot of different kinds of signatures going on with this thing. But if we click on this item, for example, or anything here, we can click on View Signature, and we see that it was signed by a Microsoft timestamping service. Okay, and we also see that we can view the certificate. Okay, so this did involve a certificate to perform the signature, and it came from a trusted root, which is Microsoft's root authority. Okay, and it tells us that the certificate is okay, it hasn't been revoked, hasn't been expired, anything like that. Then that certificate, in conjunction with the SHA-1 algorithm, goes to the security catalog, and if we take a look at these items on the security catalog tab, we can see that here's actually a driver file itself, which I should see that in the background somewhere. This one right here, SIR rem fill, something like that. So that's the file, and it runs it in conjunction with the certificate itself, runs it using a SHA-1 hash, which we see right here. Okay. Now, this is what's used to help confirm that this file has not been tampered with in any way. So if somebody were to grab a hold of that file and make the smallest of changes to it, or maybe plant some kind of malware in it, something like that, then it would no longer match the thumbprint algorithm for the SHA-1 algorithm that's been run against it, and it would generate a completely different result that we see right up here. And then I guess I should have added this on here, but you can also use it to encrypt files, and or you can also use it to encrypt entire drives. Okay, this could be a thumb drive, like a USB flash drive, or it could be some kind of other memory stick like that, or it could be an entire hard drive as well. All right, that last whiteboard you saw was actually recorded yesterday. It was Saturday, and then I decided to take the rest of the day off. And then today is actually Father's Day. And as a quick tangent, I got to show you what my wife got me for Father's Day. She got me a brand new recliner. I know you can't see it very well. There it is in the background. I was just about to go out. I did go out, and I wanted to take a better picture of the chair just to show you that. But wouldn't you know it, my son was sitting in the chair, commandeered it, and he's playing video games out of it. Okay, so goes to show you who's boss around here. Anyway, so for the rest of Father's Day, we'll record video. How about that? So what I want to show you here, though, is something in Windows where I've got some confidential information. Now, you know, there's different operating systems that offer the same kind of thing I'm about to show you. Here I'm going to show you the encrypting file system and also BitLocker within Windows. There's equivalents to that in the Mac OS. There's equivalents to that in the Linux OS, and so on. I'm just showing you the Windows version. And by the way, you don't have to memorize how to do any of this. I'm just showing you how encryption can be used. So if we take a look at this folder here, it's my secrets hard drive. It says, do not look at this. So, of course, as soon as you have a folder named that, someone's going to double-click on it and see the secrets. And so then they see, oh, a secrets document. And then they double-click on it. Yeah, okay, it's true, people. I eat too much ice cream. That's a secret, though. I don't want other people to know about that, as if they couldn't tell by looking at my rotund physique. Anyway, so how am I going to protect this document so that just the casual passerby who sits down at my computer and logs on won't be able to see it? Well, what I'll do is I'll go into Properties here, and then I'll go into the Advanced Properties, and I can choose this right here, Encrypt Contents to Secure Data. Having done that, I just click OK. It'll ask me if I want to encrypt the entire folder or just that particular document here. When I click OK, I'm going to say just the file for my purposes right now, but normally probably a better practice to choose the parent folder. The reason why is that anything else that I place inside of that folder will automatically be encrypted as well. Okay, so then I'll just click OK, and we'll notice that the color will change with this file here in a moment. It'll become green, and there it is. And if I zoom in on it, you can see, sure enough, it's green. This is the visual indicator that this is an encrypted document now. Now, to me, it's transparent. I can double-click on it, and there it is. I can modify it. I can save it again, close it. You know, it's really all the same from the end user's perspective. But there's actually a certificate that's associated with this that if we go back into the properties after it's been encrypted and click on details, we'll see here that there was a certificate for this user. There's a certificate thumbnail here, which is a unique signature, not really a signature, but it's a unique identifier for this particular certificate. If I want to click on it and look at it, I can click on back up the keys, for example. I can look, there's a recovery certificate as well. What this means is that if I encrypted this document as the trainer account right here, and then for some reason my profile got corrupt because my certificate's stored in my user profile, if that got corrupt or deleted or something like that, there might not be any way to recover this particular file. Well, there's also the administrator in the domain that by default will also have a recovery certificate. So that person could log on here with their certificate and then also decrypt this document. Now, once again, all of this stuff that I'm telling you here, not going to be on the exam per se. I'm just showing you ways that encryption can be used, and it might be interesting if you have any desire to encrypt your documents. Now, as far as where this certificate exists, like I said, it exists in the user profile, but you can also go to a command prompt or a start run, something like that, and write MMC and press enter. Then when you do that, it'll open up a console, and from there you can click on File, Add, Remove, Snap In, and choose Certificates. I'll just do that here. You can see certificates. Then it will ask you if you want the user or computer certificates, and I added in both here because I'm going to use this again later for the computer side of things. However, when I encrypted that file just now, it got a certificate from my certification authority, which is a different computer within my domain. It's called a Enterprise Root Certification Authority. Okay, now you don't need to memorize any of this. I'm just pointing out how all this can be used. This certificate right here has both a public key and a private key. For example, it says right there you have a private key that corresponds to this certificate. It's the private key that's necessary to decrypt this. It was encrypted with a public key, can only be decrypted with the private key. And so now if I want to back it up, I can do that from the Details tab by choosing Copy to File, or, and you'll get this a lot in Windows client operating systems, you'll get a notification down here in the area down at the lower right that keeps saying back up your keys. Well, you don't get that in the server as much, but here I can open it up where we are right now and click Backup Keys, and it will start a wizard for me. And you would, of course, want to put this in a secure location, and you can then back it up, and it'll back up your private key as well as your public key, and that's why it's giving me this right here. Because if I'm going to back up my private key, which is very sensitive, I need to have some kind of security to unlock it. I need to be either a user or group or a member of that group, or I need to have a specific password that I know about. Let me just enter something in here. Okay, and then next, and there's really not that much to it except you got to make the passwords match, for crying out loud. Let's try that again. And there we go. Okay, so then we could create a file name for this. I'm just going to put it on the desktop for now, but normally you'd want to put it on some other media, like a thumb drive, or burn it to a disk somewhere, and then put it in a locked, physically safe location. And I'll just call this my cert key EFS. Okay, like that. I'll save it, and then next. And that's pretty much it. Finish, and then we'll see it on the desktop here in the background. Let me close all this up. Close, close, close. Okay, and then there's the certificate. Later on, if my profile ever got corrupt or something like that, if this was in a safe place, like on Shiny Media or a thumb drive or something like that, I could just drag that back over here, double-click on it, and then it would allow me to re-import it using this wizard. I'm going to cancel it because it's kind of a next finish thing. But that's all there would be to that. Now, if anybody does not have my logon credentials, they will not be able to use this certificate. I would have to log on with my username and password. It unlocks the certificate, and then I can use it against this file. If somebody else logs on, let's see what happens. Alright, so here I've switched over. I've logged on as a different user, and I want to illustrate to you there that with the whoami/all, the user's name is Alice, and they are an administrator. They're built-in administrators, they're domain admins, so you see that they have a pretty high level of authority, and there's really nothing that they will be hidden from. Okay, so she's going to be able to click on the secrets hard drive, double-click on this folder that says do not look at this, but because she doesn't have a private key that corresponds to the EFS encryption that's applied here, when she double-clicks on it, she just gets an access denied, and it's not really because of permissions, despite the way the message looks. It's really because she does not have the appropriate certificate. Now then, let's take a look at another kind of encryption that you might be able to use, and that would be BitLocker drive encryption instead. Instead of encrypting an individual file or folders, this will encrypt the entire hard drive, and everything that gets on there will be encrypted. The advantage of this is if this flash drive, this is a flash drive, but you can do it on fixed drives as well. If any of the drives or the laptop or whatever got stolen, someone else could take that drive, and even if they don't have a logon, they could do an offline attack against it. So for example, they could just plug in this USB flash drive into their computer, take ownership of it, and then change all the permissions so that they can see all of the contents of that drive. It's really very simple to do. However, if I use BitLocker drive encryption, and again, other vendors and operating systems have equivalents to this, then once it's encrypted, then it cannot be decrypted by doing an offline attack. They would have to have a special unlock key and have knowledge of that key to be able to do this and so on. So let's see how this would work. I could right-click on here, and I'm in Windows 7 right now, but it's very similar to this in almost any current version of Windows. You just right-click, turn on BitLocker, and then you can use a password to unlock the drive, or if you have a smart card, you can use that. There's also something called a Trusted Platform Module, or TPM, that's integrated into many motherboards, particularly newer laptops. And that will store the keys in that hardware device, that integrated device, into the motherboard. Then when you start up the computer, it will look at the boot environment to see if it's changed. And if it hasn't changed, then it will unlock the TPM and allow the drive to become unlocked as well then. And the reason why it looks at the boot environment is because that's how it determines whether or not it's an offline attack or not. So we'll use a password here, and I'll just again enter something in. Hopefully I can type better than I have been earlier today. And then we'll just click on next. Then what we'll do here is save the recovery key to a file, or we could print the recovery key. This will be useful if, for some reason, I couldn't remember the password. This is kind of my backup method for being able to recover it. Okay, so I'll save the recovery key to a file. I'll just put it on my desktop for the time being. And I'll just call it that and leave the default name there and save. And then we'll click on next and start encryption. Now, it's not a very large hard drive. It's only 200 and some megabytes, but I'll go ahead and let this complete, and then we'll come back and take a look. When it's complete, we get this message that the encryption of E is complete. There it is. I can double click on it, and I can still work with this transparently. Okay, so there's nothing big deal here. I have apparently some time traveling secrets there, a time traveling car that I've been able to invent, and we find out that it needs gigawatts. Well, nobody knows that except for you and me right now. Okay, we don't want that to fall into the wrong hands, and it's encrypted. Now, I was mentioning earlier there's recovery for this as well. What if I forgot the password, and now we can't invent the time-traveling car, we can't use the time-traveling car because we don't know the secrets anymore? Well, I can open up that document that I saved to my desktop, and this just gives you the instructions, but the main idea here is I would have to enter in a BitLocker recovery key like this as kind of a backup method. So that would mean that I need to store that file in a very secret and protected place. Okay, so I pulled the drive out. It's just a USB flash drive. I'm going to plug it back in now, and you'll see here that when we do so, first of all, it's connecting to a Windows virtual machine, so I'll connect it to Windows. You don't always have to do that unless you're working with a virtual machine. We see here that it's locked, so it prompts me to type the password to unlock the drive. And of course, I can't get anything from it unless I enter that password in. Okay, and then we'll click on unlock. We can also do it automatically from this point forward. Okay. Now, if I would take that to some other computer, I could still unlock it provided I had the recovery key or provided I had that password. All right, so here I've jumped over to my Server 2012 R2 server, and I have a web server that's on a different computer here in my same network, and it's just web01.nuggetlab.com. Now, what I've done here is I've just gone to some photographs that I took this past autumn in Colorado, okay? And so maybe I want to make these available for sale. Now, right now, probably nobody wants to buy from me, not because the picture's ugly, I hope, but because if we zoom in on things here, up at the top, we see that it's HTTP, not HTTPS. Now, we know that it's still possible to use SSL strip and things like that to get secure information, but hopefully, in most cases, that won't work, and at least we want to give people some peace of mind, right? So when they see HTTPS up there, maybe they'd be willing to input their credit card data. But right now, I don't have the facility to do that. I don't have a certificate that could secure this website. So what I need to do is to go to my certification authority, which I've already installed here, and it's integrated into the domain as an enterprise root certification authority. Now, you don't need to memorize all the stuff that I'm showing you here. Again, I'm just showing you how certificates can be used. You're not going to get these specific questions on the exam if you're a test taker, all right? Now, the problem we have right now is there is a web server template. These are all templates, and I can get certificates based on how these are all configured. But the web server one is not really suitable quite yet. And I can't edit it. So what we have to do is to duplicate it, and that's what I did right up here. So you would right-click on Certificate Templates to choose Manage, and then we would go down here to Web Server, right-click on it, and choose Duplicate Template. And then we would name it something else, and then we would specify the cryptography. Remember, this is all handled by a bunch of brainiacs that probably went to the Elite Taekwondo and Math Academy. I know it seems random, but I passed by this a while back, and I couldn't help but take a picture of this business. I don't know, I guess if they don't like your math skills, you can beat them up with your Taekwondo or something like that. But anyway, so they come up with all of this stuff, and there's different cryptographic providers here like Diffie-Hellman, RSA. These are, again, are all mentioned in my study guide over here, and you'll see the key lengths and how they're commonly used. For example, you might need to know that Diffie-Hellman's commonly used for SSL. Okay, so just take a look again at the study guide there. But anyway, I configure that as necessary to make it suitable so that I can then issue certificates based off of that template. The next thing I need to do is to go to the computer that needs that template, and that's my web server itself. And more specifically, it needs a certificate based off of that template. Now, how do I get a certificate? Well, on the certification authority that we just looked at a moment ago, I set it up also so that you could connect to it through a website. So here on the web server, I'm opening up a browser to connect to my certification authority at dcnugget01.nuggetlab.com. Of course, yours would be different if you set yours up. That's just my example here. What I want to do, though, is to request a certificate and an advanced certificate request, and I want to create and submit a request to that certification authority. Then what I need to do is it's just going to say yes, it's going to perform a certificate request on my behalf. I'm going to allow that. And I specify what kind of certificate I want. I want the web server for Nugget Lab. And then I would fill in all of this information. Now, one of the key parts of this, if you actually use this in production and you want to pursue this any further, besides just knowing about cryptographic key pairs, is that I need to enter in here the name. Now, what name would I be tempted to enter in? How about James Conrad? Well, that would fail. How about Trainer? Because that's the account I'm logged on as. That would also fail. Why is that? Because the name that it's looking for is not the name of a person, it's the name of the entity to which someone's making a connection. People will make a connection to HTTPS, and then they'll be making a connection to, web01.nuggetlab.com. So that's what I got to type in here, web01.nuggetlab.com. If you don't do that, then they'll get the certificate error message, and then people get scared and they click on cancel and close the web page. Okay, so we don't want that. Then you would fill in all the rest of this, and I'll just fill this in offline and come back. And so I filled all the rest of that in, and then we just go down here, and we would then click on Submit. Notice that it does mark the keys as exportable as well. That means that there's going to be a private key there that I can export, which I'm going to need to do later on. So then it says again, do you want to allow the website to perform a certificate operation on your behalf? I'll click on Yes. Apparently, it has issued the certificate, because it says right here, install this certificate. So I'll click on Install, and it has been successfully installed. Now, where did it install it? How do I gain access to it? Where is that thing? Well, it's not just in my documents. You double click on the certificate or something like that. It actually gets stored in the profile, and we see here that I've got an existing trainer certificate for the EFS that we did a little earlier. If I refresh the screen, however, then we should see that we also have this one, web01.nuggetlab.com. Problem is, it's in the wrong container. It's in the current user certificates, but that's the only way that it can do it, because it was a user that requested the certificate. I really want that certificate to go down here. All right, now I've got another one for a different purpose, but that won't work for the web. So what I'll do here is I'll right-click, and again, you don't need to memorize all this. I'm just doing kind of an exercise, if you will, show you how you can use certificates. So I'm going to click on Next through the wizard. I'm going to export the private key, which will require a PFX style or type of certificate, and then I'm going to specify a password, but you can also be a group or username. So I'm going to enter in a password. And I've been having trouble with passwords today. Hopefully they match. They do. Okay, good. And then I'm going to put this, just for the time being, on my desktop, but you would normally want to put this in a very secure location, because if anyone gets a hold of this, then they could potentially expose your private key. Now, I have a password that helps, but I'll just put this in there. Web cert. I'll put it like that. So we'll save that onto my desktop, next, and finish. And then the export was successful. Then I go to my local computer certificates, right-click here, choose all tasks, and import certificate. So then I'm going to import next. Going to go to the file name that I specified earlier, which was, it's not showing up because I got to change the type of file. It's a PFX type, and there it is. Okay, so then open that up, and it's really just a next, finish after I enter in the password. And then next, and finish. That's pretty simple. And then if I refresh the screen, actually it did it itself. There you see, there is the certificate. Now that's going to be useful for server authentication, and in particular, web server authentication. So let me minimize things up a little bit here and go back to IIS. Here then I would go to Bindings, and I need to associate that certificate with this website. And I would click on Add, and I want it to be HTTPS, okay, like you see right there. And then I'll need to select the appropriate certificate, which, what do you know, but there it is. It does happen to automatically appear. If it doesn't show up, I can click on Select and Browse for it. So now we see that we are configured properly. If I click on OK now, then we should be all good. And then I'll close that up. And now what I'll do is I'm going to go back over to the page where I had the web browser open earlier. Here it is. Okay. And now I should be able to type in HTTPS up here. So I'm typing in an S up there. Let's go up to the top. Hopefully I don't biff this somehow. I didn't practice this, really, so hopefully... okay, good, success! Okay, so now we've got HTTPS up here. Okay, and we do see over here on the left the little padlock. If we click on the padlock, we see that indeed it was secured with a particular certificate. I can even view the certificate if I'm suspicious of it and I want to see, hey, where was this thing issued from? Oh, this is a web server or a certification authority that I trust. And so I know we're okay. All right, now, so then we have it good. Okay, we're all set with HTTPS. The only thing I need now is to set up some kind of a shopping cart. All right, folks, with what's left of Father's Day, I'm going to go to the living room and try to dethrone my son from what he thinks is the new gaming recliner. I'm going to have to teach that boy a lesson. Anyway, let's take a look here at what we learned about cryptography. We took a look, first of all, at the basics of cryptography and how it does its job. One of the key parts of that is the difference between symmetric algorithm, which uses the same key to both encrypt and decrypt, and asymmetric algorithm, or you know what? I think I need to remove an S there, don't I? That looks a little better. Sorry, folks. Anyway, I looked at the difference between those two things. Then we took a look at key pairs, which is an asymmetric kind of an algorithm, where you have, for example, a certificate that uses a public and a private key. Then we looked at using encryption by example of EFS, BitLocker, and finally, secure websites. Well, I hope this has been informative for you, and I'd like to thank you for viewing.